People are always best when you first meet them, warm and insincere, fresh and romantic, from morning sunlight chats to late-night dinners. But who can withstand the test of time? In the end, everything goes, from saying everything to having nothing to say. But if we turn our gaze to the cosmos, you might begin to understand that this process is neither accidental nor tragic. It's a natural law. In cosmology, there's a final fate hypothesis called heat death. In the 19th century, Lord Kelvin first proposed applying the second law of thermodynamics to the universe. He predicted that if entropy keeps increasing, the universe will eventually reach a state of thermal equilibrium, energy distributed uniformly. No more ordered physical processes possible. In that state, no new stars form, no gravity-driven structures assemble. The universe becomes utterly silent. It's like a relationship, from the initial passionate rush to the final silence and cooling. Sounds familiar, doesn't it? Like the ending of our love stories. So the question is, why are we always so fervent at the start, struggling through the middle, and ending up ordinary at last? Is human nature simply this way, or is this actually determined by the physical nature of time? Physicist Stephen Hawking explained the concept of the arrow of time. It points in the direction of increasing entropy, from low entropy to high entropy, from order to disorder. Love, in fact, can be viewed as a local, low entropy state. When you first meet someone, everything is new, unknown, full of possibilities. That is a low entropy relationship. Information incomplete, interactions abundant, the system vibrant. As understanding deepens, behavior patterns emerge, expectations crystallize, and entropy rises. It's not that you stop loving, it's that the system moves toward a steady state. Stability should be ideal, but in physics, it often means a system at rest after its energy is spent. If everything is destined to flatten out, should we still begin? Think about the universe's beginning. In the standard cosmological model, the universe started in a hot, dense state, known as the Big Bang. At that moment, time and space were born together. All the possibilities of the universe were concentrated in an almost invisible instant. Like when you first see someone, you know nothing about them, yet anything could happen. That uncertainty itself is the charm of life. The Big Bang nucleosynthesis theory, proposed by physicists like George Gamow, points out that in the universe's earliest minutes, the first hydrogen, helium, and other light elements formed. In that blazing moment, matter wasn't yet differentiated. Energy was dense. Particles collided violently. The universe was hot and chaotic, like the earliest stage of love. So close you can't tell you from me, thinking it will always be this way. But the universe will expand and cool, and human relationships will inevitably step out of intimacy. Einstein's general relativity tells us that gravity is the result of matter bending spacetime. Two people drawing close isn't necessarily fate or destiny. Maybe your hearts have enough mass to bend each other's orbits, but once the gravitational fields between you become unbalanced, you inevitably drift apart. This isn't a moral failing, it's a question of structural stability. Have you ever thought that a black hole can also be a metaphor for love? It was once a star, burning to the extreme, and ultimately collapsed under its own gravity, into a region even light cannot escape. It's still there, and you know it exists, but no signal can enter or leave. Like some relationships, they have lost all channels of communication, yet persist in your heart in a heavy form. Hawking radiation tells us, however, that even black holes will slowly evaporate through quantum effects. Even the seemingly eternal silence will eventually dissolve into the background noise of the universe, becoming the dust of memory. So why do we still love? Why do we still begin new relationships? The carbon, oxygen, and iron in our bodies all come from the interiors of stars, from the death explosions after nuclear fusion. Because we come from the same universe, we resonate with one another. Love is two briefly existing particles, recognizing each other in the vast cosmos, and producing resonance. That connection itself is a miracle. So even if the end is silence and separation, we are still willing to love, to meet, to share sunlight and dinner. Even if it's just a flash of light, it's worth gazing up at. I'll leave you with a question. If you know all relationships will experience entropy and cooling, would you still choose to begin? Search for the answer, not to find a yes or no, but to understand that we aren't living to reach eternity. We're living to leave behind a mark that we once lived passionately in a universe headed for cold silence.